Okay, guys. So today, what I'm going to do, I'm going to share notes from section 1.2, which is application of linear equation. This section's it's about solving word problems. So we'll go over some of the problems, solve them together, and then after the video, I will share with you guys also my notes and the PowerPoint. Okay. So, oops, going to go straight to problems. So before we start solving the word problems, just couple review. We have to recognize the keywords, especially at the beginning of section 1.2 when you have to translate sentence into mathematical expression equations. So addition, when you have in a sentence sum, more than, total, all those three words stands for addition, which is plus sign. Subtraction, so when we have in the word problems words like difference, less than, minus, they represent subtraction. Multiplication, when we talk about multiplication, that's the product or times. Division, when we talk about division, quotient, divide by, or per, those three words, they will describe division, which we can just put the fraction bar. And the word is stands most of the time for equal sign. So here I want to go over the example. Okay. So we have to rewrite each statement as an algebraic expression or equation. So the first one, we have 7 more than 3 times a number. So the solution here will be 7. Word more stands for plus, 3 times a number. So 3 times stands for multiplication, and number, we don't know what number. So this is your variable. I'm just going to introduce x. So 3x. Okay. Next one, we have 5 less than twice a number. So next to the word less than, I'm going to put like a star, because when you have a less than, you actually should read the sentence from right to left. To left. Less than, of course, we'll talk about subtraction. So twice a number, that will be 2x, because I don't know what number we're talking about, less than 5. So minus 5. So that less than, again, means we're subtracting 5 from twice a number. C, we have 3 times the quotient of a number and 11. So solution here will be 3 times. Times stands for multiplication. The word de stands for parentheses. That means you have to open the parentheses. And we're talking about the quotient. Quotient stands for division. So I'm going to put fraction bar of a number. So we don't know what number we're talking about. So I'm going to put x divide by 11. Okay. So you can leave the solution that way. So this is the same as 3 times x over 11. Okay. Or we can put it as 3 divide by, because the quotient stands for division. But first was 3 times, I'm sorry. So we have 3 times, and then we have the quotient, which is division of x and 11. Okay. So both solutions are correct. This one right here and this one. Okay, next one. We have the sum of a number and 9 is 1 less than half of a number. Okay, so here we're talking about the sum, which is the major operation is plus. So we have addition of a number, so x, because I don't know that number, and 9, so I have x plus 9, stands for equal sign, 1 less than. So again, that word less than. Okay, so that means I will have to subtract 1 from half of the number. So half of a number will be 1/2 x, because x stands for the number. So this is the expression, this is the equation for sentence D. And the last one, E, we have the product. Product stands for multiplication of a number, so that will be our x, and 4 is stands for equal, 1 more stands for plus, then a times the difference, the stands that you're going to open the parentheses right here and close it right here. So let's create this equation. So we're talking about the product, multiplication of a number and 4. So I'm going to put x times 4 is 1 more. So I have 1 plus, then a times multiplication. I have the word then, which stands for the parentheses, the difference, so I will subtract, of 10 and the number. So 10 minus x. So this is exactly how you're supposed to read it. I'm just going to modify that a little bit. X times 4 is just 4x equal 1 plus 8 times 10 minus x. So that will be the solution of this problem. Okay. So next part of section 1.2, just giving you some steps how to convert verbal statement into mathematical sentence. So you guys have all those steps. Okay, I will read that for you to read it. And I just want to move straight to the example. Okay. So the first example which we're going to solve, it's a solving application involving unknown numerical quantities. So technically solving word problems using linear equations. So we have Roger and Terry were both quarterbacks in the National Football League. In 1973, Staubach threw 3 touchdown passes, more than twice the number of touchdown passes thrown by Bradshaw. If the total number of touchdowns passes between Staubach and Bradshaw was 33, how many touchdown passes did each player throw? So the idea of solving word problems with linear equation is to introduce only one variable. Okay, so we only want to introduce one variable. So in this problem, we have 2 football players, Staubach and Terry Bradshaw. So right here in this sentence, in 1973, when they say that Staubach threw 3 touchdown passes more than twice the number of touchdown passes thrown by Bradshaw. So since they compare Staubach to Bradshaw, so your variable should be B. Okay, your variable should be B, which means how Bradshaw's touchdown passes. So technically, how many touchdown passes Bradshaw throw. Okay, so that will be B, stands for Bradshaw touchdown passes. Okay, so of course we have another football player, which is Roger Staubach. So now we have to express touchdown passes, which Roger Staubach did. So how are we going to express that? So here, Staubach touchdown passes. So we want to express that using variable b. So I'm going back to this sentence. Okay. And right here, they're saying that Staubach threw 3 touchdown passes more. So this is 3 more stands for plus, then twice the number of touchdown passes thrown by Bradshaw. So the number of touchdown passes thrown by the Bradshaw, this is our variable b. So it will be 2b. So touchdown passes we're going to express by using the expression 3 plus 2b. Okay. And now we need to create the equation. So to create the equation, we will go to the last sentence right here when they're saying that the total number of touchdown passes between those two football players was 33. Okay. So our equation, which will help us to solve this problem, we know that together they they had 33 touchdown passes. So Bradshaw touchdown pass, which is B, plus Staubach touchdown passes, which we express by 3 plus 2b, equal 33. And we just need to solve this equation. Okay. So to solve this equation, we have b plus 3 plus 2b equal 33. I remove the parentheses. Combine like terms. So 1b plus 2b will give us 3b plus 33 equal 30. Plus 3 equal 33. Subtract 3 from both sides. And we having 3b equal 30. And just divide both sides by 3. So we're getting divide by 3, and that will give us that b it's equal 10. Okay. So we have that b it's equal 10. So don't forget that b stands for Bradshaw touchdown passes. So that will be our solution. Bradshaw had 10 touchdown passes. So now Staubach will have 3 plus 2 times 10. So we're going to replace b right here with 10. Going to plug in 10. Okay, so we have 3 plus 2 times 10. So that will be 23. So Staubach had 23 touchdown passes. Bradshaw had 10. So that was one of the problems of solving application. So we have to technically create linear equation and solve that linear equation. Again, you only want to introduce one variable. So next one is solving application involving decimal equation, money mixture, and interest problems. So here, this is the example which we're going to cover. Billy has $16.50 in his piggy bank, consisting of nickels, dimes, and quarters. Billy noticed that he has 20 fewer quarters than dimes. If the number of nickels is equal to the number of quarters and dimes combined, how many of each coins does Bill have? So in this problem, actually they're asking for three things. We need to figure out how many dimes Bill had, how many quarters, and how many nickels. However, we only want to introduce one variable. So when you guys will read the second sentence, they saying that Billy noticed that he has 20 fewer quarters than dimes. So we comparing quarters to dimes. That means your variable will be amount of dimes. Okay, so I'm going to introduce D. It's going to be our variable. So this is number of dimes Billy had. Okay, so now when we're talking about quarters, so we're going to express number of quarters and we're going to translate this part. Billy noticed that he has 20 fewer quarters than dimes. Fewer stands less than, we're subtracting. So Billy noticed that he has 20 fewer quarters than dimes. So we're going to translate that. So numbers of quarters, it's 20 less than dimes, 20 fewer than dimes. So D stands for number of dimes. We're going to subtract 20. Okay. So that's that expression, 20 fewer quarters than dimes. Now we have to figure out number of nickels. So if we're talking about numbers of nickels, let's just read that number of nickels right here is equal to the number of quarters and dimes combined. Okay, so amount of nickels is equal to amount of quarters and dimes combined. So this is quarters plus dimes together. So to express that, D is amount of dimes plus amount of quarters, which is D minus 20. Okay. So let me just simplify that. So we have D plus D minus 20. So technically this is the same as 2D minus 20. So 2D minus 20 stands for number of nickels. D stands for number of dimes. And number of quarters, we're going to use the expression D minus 20. Okay, so everything was expressed using variable D. So now it's time to create the equation. So our equation, to create our equation, we're going to use the information that Billy has $16.50. So $16.50. So together that's the amount of money he has it. So let's talk about dimes. We don't know how many dimes he has, so I'm going to put D. And the value of dimes is 10 cents. So you're going to multiply amount of dimes by the value of money, which is 10 cents. So 10 cents times D, which is amount of dimes, plus. Now I'm going to talk about quarters. He has D minus 20. So he has D minus 20 quarters. And if we're talking about value of money, quarters is 25 cents. So we're going to multiply 25 cents by amount of quarters he has. So 25 cents, you're going to use the decimal point 25. Plus, and now we're talking about nickels. So the value, if we're talking about money, nickels is 5 cents. So we're going to express that using decimal. This is 0.05. So 0.05 has to be multiplied by amount of nickels he has. So amount of nickels he has, we simplify that d plus d minus 20. So this is 2d minus 20. So this is our equation, which we're going to use to solve this problem. So first what I'm going to do, since I'm not a fan of decimals, I'm going to find lowest gamma multiple, okay? Lowest gamma multiple. So 0.10, it's technically 10 over 100. 0.25, this is 25 over 100. And 0.05, this is 5 over 100. So lowest gamma multiple of all those numbers which have decimals will be 100. So lowest gamma multiple is equal 100. So we're going to multiply both sides of the equation by 100. Okay, so we'll just continue here. So we have 100 times the left side of the equation, which is 0.10d plus 0.25d minus 20 plus 0.05 2d minus 20 equal 100, which is the lowest gamma multiple, times the right side of the equation times 16. So I'll just put this at times 16.50. Okay. So now we're going to solve this equation. So here what we need to do, we need to distribute that 100 to each expression which you have in the parenthesis. So that will give us 100 times 0.10d plus 100 times 0.25d minus 20 plus 100 times 0.05 2d minus 20. Like you guys see, I'm not removing parentheses, equal, again, 16.50 multiplied by 100, we're moving decimal two spaces. So we have 1,650. Okay. So now we're going to solve the equation. Here, 0.10 times 100 will give us 10d plus 100 times 0.25, this is just 25, d minus 20, plus 5, 2d minus 20, equal 1,650. So now when I don't have decimals, I'm just going to remove the parenthesis. So 10d plus 25d, and then we have 25 times 20, 500 minus 500 plus 10d minus 5 times 20, which is 100, equal 1,650. Combine like terms. So we have 35d plus 10d, that will be 45d. And then we have negative 500, negative 100, so that will be negative 600, equal 1,650. So we need to solve for d. I will add 600 to both sides. Okay. And when we add 600 to both sides, we have 1650 plus 600. So here that will give us 2,250 and 45d. Last step, just divide both sides by 45. And I have d equal 2,250 divided by 45, I got 50. So D is equal 50. That means that we have 50 times. So now when we're talking about quarters, okay, so for quarters, so number of quarters. So for quarters, we use the expression D minus 20. So we're going to replace D with 50. So we have 50 minus 20. So we have 30 quarters. And for number of nickels, so for amount of nickels, we use the expression 2D minus 20. So that will be 2 times 50 minus 20, which is 100 minus 20, that will be 80. So we have 80 nickels. Okay. And of course, you can always check if you solve the problem correctly. So we know that together he has $16.50. That's when we talk about money here. So we know that he has 50 dimes. So technically 0.10, we need to multiply by 50. Plus he has 30 quarters. So amount of quarters, which is 30, we're going to multiply by 0.25 times 30. Plus he has 80 nickels. So nickels, it's 5 cents. So 5 cents multiplied by 80. And if you guys will check that, we will definitely end up with $16.50. So this is just checking my work. Okay. So this is how you're solving problems involve money. So don't forget that $16.50 represents money value. So that's why when I create the equation to solve that problem, okay, I had to use the correct money values, like 0.10 for 10 cents, 0.25 for 25 cents, and 0.05 for 5 cents. So next problem, it's in section 1.2. It's a problem which involve still decimals, okay? But here we'll talk about mixture problems. So when we're mixing two different products, two different solutions to get brand new solution. And this is the example on slide 10. Okay, so let's just read this problem. So here they're asking how many milliliters of 70% acid solution must be mixed with 30 milliliters of 40% acid solution to obtain mixture which has 50% of acid. Okay, so here this is the situation. We mixing two different solution. So here we mixing solutions which contains acid solution. So we know that we have 30 milliliters of the solution which has 40% of acid. We mixing that solution with the second solution which contains 70% of acid, and we don't know this amount. That's why you see that X here, because they asking you here how many milliliters of 70% acid solution. So this is our X. This is our variable. That's why you see that X right here. And we must mix to get a brand new solution which will have 50% of acid. Okay, so here in the picture, you guys see that expression 30 plus x that just express the amount of this solution, because we mix 30 milliliters of the first solution plus, this is what we're trying to figure out, x amount of the second solution to get brand new solution which contains 50% of acid solution. Okay, so what equation we need to create? Let's talk about it. So we know that our total amount it's 30 plus x. That's milliliters. But what we will need to do with that, we're very specific in this problem. We're talking about getting 50% of acid solution. Okay, so we need to multiply that by 50%. And 50%, this is just 0.5. When you change percent to decimals, you just divide that number by 100. So you need to multiply that by 0.5 because our brand new solutions has to have 50% of acid solution. Okay. Now, what we're mixing to get that brand new solution? We're going to mix 30 milliliters of the solution which has 40% of acid solution. So that 30 milliliters has to be multiplied, has 40% of acid solution. So to calculate that amount of acid solution, you need to multiply by 40%, which is 0.4. So I replace that 40%, change to decimal. So this is just 40 divided by 100, which is 0.4. Okay, so that's very important because our new solution, we're very specific. We want to get the amount of those acid solution. Plus, we're mixing the second solution, which has 70% of acid. So 70% is the same as 0.7. So those 70% of acid solution, and we're trying to figure out the amount which we need to mix. So that's our x. So this is the equation which you will need to solve, apply to solve the mixture problems. Okay. So again, those numbers which you see right here, they represent acid amount. Acid amount. So to calculate the acid amount of the first solution, 40% times the amount which I have it here, which is 30. The amount of acid solution from second solution. This one has 70%, which is 0.7 times the amount which I'm going to mix. And our brand new solution has to have 50% of acid. So 50%, which is 0.5, multiply by the total amount, which is 30 plus x. So again, this equation stands for amount of acid. Okay. Okay. So again, here, this is the amount of acid from, of course, in milliliters from first solution. Amount, so the same thing, amount in milliliters of acid from second solution. So here, this is amount in milliliters of acid of our final solution. Since final solution needs to have 50% of acid, that's what we'll multiply by 50. Okay, so now we just need to solve the problem. You can solve it the same way like I did it. Either if you want to, you can work with decimals or just remove those decimals. First, what I'm going to do, I'm just going to simplify because 30 times 0.4, this is just 12. So I have 12 plus 0.7x equal 0.5 times 30 plus x. So lowest common multiple here, since I have 0.7, which is 7 over 10, 0.5, it's 5 over 10, so lowest common multiple will be 10. I'm going to multiply both sides of the equation by 10. 10 times, again, I just prefer to work with the integers. So 12 plus 0.7 x equal 10 times 0.5. Oops. For times, I'm going to use that because x stands for my variable. So 10 times 0.5 times 30 plus x. Okay, distribute. So we have 120 plus 7x equal 5 times 30 plus x. Distribute 5. So we're getting 5 times 30, 150 plus 5x here, and 120 plus 7x. And we're just going to solve for x. I'll subtract 5x from both sides. So we have 120 plus 2x equal 150. Subtract 120 from both sides. And we will get 2x equals 30. Divide both by 2. And that will give you x equal 15 milliliters. Okay. So we end up with 15 milliliters, which is the solution. So the answer here is we must mix 15%, 50 milliliters of 70% solution to reach the desired mixture. Okay. So this is how you're solving problems when you have percentage mixture problems. And in section 1.2, I have 2 more problems with distance. One is with distance and one is with job. So next what we're going to do, we're going to solve the problem involving distance. So in this problem, I'll just read it first. Airplane that can maintain average velocity of 320 miles per hour in still air, which means perfect solution situation, no wind at all, is transporting smoke jumpers to forest fire. On takeoff from the airport, it encounters a headwind and takes 34 minutes to reach the jump site. The return trip from the jump site takes 30 minutes. What is the speed of the wind? How far is it from the airport to the fire? So we have 2 questions. This one we're going to answer after we will figure out what is the speed of the wind. Okay. So W, here W will stand for speed of the wind. Here in this example, the hint is to use distance formula. So to calculate the distance is equal rate times time. Rate times time. Rate stands for speed. Okay. So I think the best way to express this problem it's going to be by putting the table. Okay. So distance, it's rate, which is the speed, times time. Time, when you calculate, so here the time we'll have to use hours because they give you the velocity of the plane and they're using miles per hour. So that's why time has to be, we have to use hours as units. Okay. And distance. So of course we'll use the distance formula. So technically rate times time will give you that distance. Okay. And in this problem we have two situations. So we're talking about the airplane which flies against the wind and with the wind. So first I will talk about situation of headwind. So technically when the airplane flies against the wind. So headwind. And flying with the wind, that will be tailwind. Okay. So let's start going back to that problem and read the information. So we know that average velocity, which means average rate of the plane in a perfect situation, it's 320 miles per hour. So we should think about that this is the speed of the airplane in the perfect situation. Now, on takeoff from the airport, it encounters headwind, and headwind, that means we are flying against the wind. So when we will talk about the rate of the plane, since here we're flying against the wind, I'm going to express the rate of that plane when we go headwind against the wind as 320. That's the rate of the plane minus the speed of the wind, which is W. So of course the airplane will have to slow down because we encounters headwind. Now, when we're talking about the time, so that trip takes 34 minutes. Don't forget that our time has to be expressed in hours. So you need to convert that 34 minutes into hours. So to do that, just divide those minutes by 60 because 1 hour has 60 minutes. Reduce the fraction, which means divide both by 2. And that will give you 17 over 30. And this is in hours. If you prefer decimal, go ahead. I just prefer working with fraction. So now we're going to calculate the distance. So distance is rate times time. So we'll multiply those two expressions, which means 320 minus W, that's the rate of the plane against the wind, times time in hours, which is 17 over 30. So now we're talking about the situation when we fly with the wind, when the airplane fly with the wind. So now The return trip from the jump site takes 30 minutes. So let's focus on this one. So 30 minutes, we need to convert to hours. So this is the same as 30 divided by 60, which is just 1/2. So it takes half of the hour to go back, and the return trip from the jump site takes 30 minutes. And what is the speed of the wind? So the jump site takes 30 minutes only. That means we flying with the wind. So tailwind, we're flying with the wind. So this 320 miles per hour, this is the speed of the airplane in a perfect situation. Since we're flying with the wind, the speed will increase. So that will be 320 plus the speed of the wind. So to calculate the distance, using distance formula, rate times time. So right now our speed of the plane increase. So this is 320 plus W. We're flying with the wind times time, which is 1/2. Okay. So it's time to create the equation. So what will be the equations? Since we're dealing with the distance, so the distance are the same. Okay, so the distance with the trip when we had the wind and coming back, it's the same. The wind has nothing to do with the distance. We're still talking about the same distance, flying and flying back. So to solve this problem, we're just going to make those two distances equal to each other. So hint, both distances are the same. So we can equal the two distances. The two distances. Okay. So let's continue with this equation. So we have 320 minus W times 17/30 equal 320 plus W times 1/2. So again, I don't like to work with fractions, so I'm going to find lowest common multiple of 30 and 2. That's the numbers which I see in the denominator, and lowest common multiple is 30. So what I'm going to do, I'm going to multiply both sides of the equation by 30. So I have 30 times, I will just rearrange a little bit, 17/30 times 320 minus W equal 30 times the right side of the equation, which is 1/2 times 320 plus W. Okay, and now I'm going to solve it. So 30 cancel, we end up with 17 times 320 minus W equal 30 divided by 2, this is just 15. 15 times 320 plus W. And now I'm just going to remove the parentheses. So 17 times 320, we're getting 5,440 minus 17W equal 15 times 320, that will be 4,800 plus 15W. And now we just need to solve for W. So just to avoid negative, I'm going to add 17W to both sides. We have 5,440 equal 4,800 plus 32W. I will subtract 4,800 from both sides. So we end up with 20 equal W, which means W is equal 20 miles per hour. So this is the rate of the wind. The wind is 20 miles per hour. Okay. So we answered the first part of this problem. They ask you what is the speed of the wind. Now we have to answer the second part. Here they ask you how far is it from the airport to the fire. So how far, we're talking about distance. So technically we just need to calculate the distance. Since the distance flying to the fire and flying back from the fire, those both distances are the same. So what we need to do, we need to replace W with any equation. You can use equation 1 for distance or equation 2. Replace that W with 20 and that will give you the distance. So let's just continue with this problem. Okay. So to calculate the distance, let me see, I will try to right here. So to calculate the distance, to find the distance, from the airport to the fire, substitute 20, W equal 20, into either distance expression. Since distance is the same. So what I'm going to do, I'm going to just select this one because it's just 1/2. It's easier to multiply by 1/2. So 320 plus W. Sorry. So I select second equation. So that's that second expression. 320 plus W. So that's the distance flying back from the fire to the airport times 1/2. And we're going to replace W with 20. So that will be 320 plus 20 multiplied by half. And the distance will be 170. We're talking about distance, so that's 170 miles. Okay. So hopefully this problem makes sense. And there's last type of problem, which is when we calculate the amount of time we need to complete the work together. Okay, to work together. So this is the last example, which we're going to cover in section 1.2. So last one, solving application problem, working together problems. Okay, and you guys solving those type of problems very similar way. That's why I'm slowly going through all the problems explaining how to do it. So we have Brad and Michael decide to paint the entire upstairs of the new house. Brad can do the job by himself in 8 hours. If it took them 3 hours to paint the upstairs together, how long would have taken Michael to paint it by herself? So they paint together. We're asking how much time Michael will spend if he'll have to paint the house by himself. Okay. So here, I'm just going to introduce the verbal. So introduce T. T, it's going to be the time it would take Michael to do job by herself. Michelle, I'm sorry. The time it would take Michelle to do the job by herself. Okay. Okay. So now I think the easier way to do it, also, I'm a fan actually of expressing all the information in table. So we have two situations here. We're talking about time needed to complete the job in hours. So that will be my first column. My second column will express portion of job, which can be complete in 1 hour. So amount of job, which can be complete in 1 hour. So the second column will represent rate, which stands for portion of job. Completed in 1 hour. So this is what we're going to do. Okay. So we have Brad. Okay, let's talk about Brad. We have Michelle. And of course, they painting that house together. So this is when we're talking about the job when they're doing together. Okay. So what we know that the Brad can do job by himself in 8 hours. So time needed to complete job in hours for Brad will be 8 hours. Okay. Now, when we will be talking about rate, which is portion of job complete in 1 hour, so we're talking about portion, how much work he can do it in 1 hour, so that will be reciprocal of 8, which is 1/8. Okay. Now, Michelle, we don't know how long it will take Michelle to complete the job by herself in hours. I'm putting T. But if I want to express the portion of the job which she can complete in 1 hour, I will have to take the reciprocal of that T. So I will divide 1 hour by T. Okay. And now when we're talking about working together, so together, we know that it takes them 3 hours to complete the job. But now when we're talking about portion of job complete in 1 hour, so amount of job which they can complete in 1 hour, that will be 1, because 1 hour divided by 3. So what will be our equation? Our equation will be your second column. Right here. This is our equation. So we're using the rate to create the equation. So equation which we need to solve to use that problem. So that equation which will describe the portion of job complete together in 1 hour. So we have 1/8 So this is the portion of job which Brad can do in 1 hour, plus 1 over t. This is portion of just the job which Michelle can do it in 1 hour, equal 1 over 3, which is the portion of the job completed together in 1 hour. Okay, so we just need to solve this equation. Again, what I'm going to do here, I'm going to use the lowest common multiple. So lowest common multiple of 8 and 3 is 24. I will multiply both sides by 24. Oops, I don't have space. So hopefully you guys don't mind that I will just squeeze it. So multiply both sides by 24. Okay, so we have, try it, squeeze it here, 24 times 1 over 8 plus 1 over t No, we can do better than that. Hold on. Since I apologize with that I confused you with that lowest common multiple, because I didn't notice that t right here. Okay. So what we can do, first of all, we can remove the parentheses. So we have 1 over 8 plus 1 over t equal 1 over 3. Like you guys see, we're dealing with reciprocal. Reciprocal of 8 plus reciprocal of t, it's equal reciprocal of 3. So what you want to do, just flip over those reciprocals. So we can just say it that this is hold on. I will have to use that else. Lowest common multiple. Lowest common multiple, but it's not going to be 24. It's going to be 24t. Because we also have that t. So we'll need to multiply both sides by 24t. Okay, so that's the lowest common multiple. 8 times 3 is 24, times t, that will give us 24t. So now I'm going to distribute 24t times 1, 8. So this is 24t divided by 8 plus 24t times 1 over t. That will give you 24t divided by t equal 24t times 1/3. So this is just 24t divided by 3. Okay, and I don't have a space to solve it, so I have to squeeze it right here. Okay, so 24 divided by 8, we're getting 3t plus, here t cancel, 24 equal 24 divided by 3, it's 8t. You guys will solve that for t, and that will give you that time. It's equal 24 over 5. Which is changed to mixed number, 4 hours and 4 over 5 minutes. So that's the time which takes Michelle to paint the house by herself. Now, what you want to do, you want to convert this one in minutes. Oh, I know I'm squeezing that. I don't like it to squeeze like that. But to convert 4 over 5 by minutes, just multiply that 4 over 5 times 30. That will give you amount of minutes, which is 4 times 30. We're getting 120 divided by 5. Okay. I'm sorry. Multiply that by 60. Because we have 60 minutes in 1 hour. So that will give you 4 times 60, which is 240 divided by 5. That will give you 48 minutes. So here the answer of this problem will be the final solution, 4 hours and 48 minutes. That's how long it will take Michelle to paint the house by herself. Again, together they paint the house in 3 hours. So I solved the equation. This is a little different. I know it's a long video, but to find the lowest common multiple, since we have the expression t in the denominator, I multiply my denominators together. So 8 times 3 give you 24, and times t, that's 24t. So I multiply both sides of the equation by 24t. That gave me nice equation to solve. And we end up with t equal 24 over 5 hours. And I was trying to be more specific here. And I convert 4 over 5 hours into minutes. That's why I multiply that by 60. And that gave me 48 minutes. So 4 hours, 48 minutes it takes Michelle to paint the house by herself. Okay, so that's it from section 1.2. I spent a lot of time on this section because it's a word problems. Usually that's the topics which students struggle. If you guys have any problems, any issue with homework from section 1.2, please feel free to send me email and I will be happy to assist you.